Hello Internet. Customer had brought in some kind of a fancy laptop. Some Asus. I'll show you the model. It's got an RTX graphics card. It's very fancy stuff. I'll show you the model later, or it'll probably be in the description or in the title of the video. Anyway, what he ended up doing is he ripped a battery connector off of the board. Where? Right there. So that's where that was. That's where the battery was, and the connector was likely still attached to the male end of the battery, and he also supplied what I believe would be a replacement battery for this. So let's see if that fits. Looks like it fits. Okay, and so today our job is to fix the ripped connector. Now let's see if how repairable that connector actually is. Let's see. I'll be trying a little different flux today to see how well that's gonna work. So this is our connector. The sad part is that the metal pieces, well, they're not ripped, so they're kind of inserted in. Oh, they're almost ripped. See, this one is like very loose, yeah, and it's actually grounded to this chip here. So first things first, let's clean up this mess. I'm going to be using Scary LFHF flux today. Wonderful. Yeah, all these layers are just kind of peeling off the board. That's not good. So let's clean this up first. This one doesn't want to cooperate for some reasons. Let's bring in a bigger gun right there. And so it looks like we're gonna have to fix at the very least 3 connections. Okay, so this flux that I'm using, I already do not like it. You see how solidified it became on the top right corner there? Yeah, it's already solidified. I don't like it. So first, let's fix what we can fix right now. I want to fix these pads that are detached from the board with a super glue. And it kind of makes me wonder what is the super glue melting point is. Because the way I want to fix this is I want to lift this pad. Actually, let me go ahead and blow it out with electric cleaner here to make sure it's super clean. Like that. And I probably want to do the exact same thing for the connector on the right. Yeah, see, because it's all ripped like that. Right there. Degreased the area. Let's blow it out even more. It looks like my blower broke. Anyway, who cares? Yes, super glue. Let's put in some super glue there, if we can find it. So how do we want to go about this? Drop a little bit of glue onto that tip. And we're going to shove that down there. Like so. And we're going to press it in and hope for the best. Okay, I think that should be enough. Now I want to get rid of that solder real quick. Like so. There we go. And that as well. Interesting. Doesn't want to get wicked for whatever reason. Let's try adding a little bit of flux to help it wick. There we go. That's better. Not great, but it's better. Okay, so we're gonna worry about that later. Right now, let's finish with the tear on the right with that ground connector or whatever this is. Right there. There we go. We might have to solder it down to this pad here. It looks like. So we're not gonna do that right now. What I'm going to do now is I want to prep this area here. And this area here. That's where it's going to be the most challenging to fix. Alright, I'm going to try a different flux, VS UHF TF. Maybe this flux is a little better, I don't know. Just experimenting today with all sorts of flux that just got delivered. Okay, so that looks great. That actually looks good. Yeah, I like that. Interesting. That actually looks very good. And it actually smells, doesn't stink at all. It actually smells somewhat sweet, so I kind of like that. That's gonna be a good flux in my book. Okay, so how do we want to go about doing this? Probably want to add a good sized pad there. Let's see, something like this. Yeah, I guess. So I guess we could probably try this. See how well that works. Because this is just a sensing pin. This is like some kind of a I2C probably. So this is not a power line. The power is probably going to be either this or that. Most likely on the right. So nice solder blob there. Cut away what we do not need. And one more. Yeah, that looks good. And here I'm just gonna lay a piece of copper that I've just stripped away from that same stack of pads. Right there. That's what I want. Now it is extremely important at this point to get rid of all the flux from everywhere. So let's go ahead and do that. Actually, I'm thinking about fixing the connection between this and that right there. I want to solder these two pads together. Let's see if we can do that. I need a little bit more copper here, and maybe a bigger soldering iron, and maybe a little bit more flux. Whoops. That was one thing I didn't want to do. But we did it anyway, so who cares? It's okay. Yeah, somehow it just doesn't want to join these two together. So let's clear it out a little bit more. Maybe it'll help. And that should do it, I think. And then this guy, we want it soldered back on there somehow. Not exactly sure how. So maybe we can do this. And maybe we can wick some of that solder off of it, because this seems like a bit too much. Okay, now let's apply some mask to fix those connections that we've made so that they do not break when we are soldering the connector back into place. Okay, the connection is now solid. Now let's go ahead and figure out what the deal is with the connector itself. And the connector has all these pads still attached to it, so let's go ahead and clean that up so that we can reattach it. Alright, so I think the way this went was like this, right? Now how do we ensure the connection that is to be made between these two guys? Well, there is one way. We apply solder onto the pads, and then we want to have a little bit of solder, well, maybe not, Actually, no. Actually, we can probably check that from the side. So let's go ahead and do that from the side, yeah. From an angle. So let's do it from an angle. It's probably going to be the best way to approach this. Let's see if I can accomplish that on camera. So the connector's going to go in here like that. And I just want to make sure that I got the ground corners here snapped in place, which I have. And so now we can actually see all of our connections, which is exactly what I want. So we can now solder these pins individually, one by one, and see if that helps. Looks like my soldering tip isn't doing very well. Let's try again. There we go. That's better. There we go. Just like Rossman said, flux is your friend. You cannot have too much flux. But what I need is a little bit more temperature here. So I'm gonna bring in the big guns and see if the big guns are gonna help us. There we go. There we go. So the one joint is like super cold. I can't get through it with the soldering iron, so I'm gonna have to warm up the board just a little bit to make sure that I get a good solder flow on that pin. It flows onto the pin, but it doesn't flow onto the pad because the pad is just pulling everything to ground and it's cold. So let's see if that works. See that one pad, second from the right? It's just kind of cold. Even with that, it's just almost there. Okay, I think we finally got it. Okay, there we go. That's what I wanted to see. So it took a little bit of heat to actually get there, but we got there. So now I'm just gonna have to clean all this up, make sure that nothing is shorted, and we can probably do it now. So I want to make sure that the middle pins are not shorted to anything. And these two supposed to be shorted. And then these three. Perfect. Yeah, so it looks like these two are ground and these three are power. Okay, so power, ground, and then these three are some kind of a I2C interface or whatever, with the battery to read its status and the state of charge and whatever else. So let's finish with the cleanup. Okay, so now that the connector is all clear, we want to secure connector to the board as best as we can because it's still a little bit loose and it holds on nothing but these pins, which isn't ideal. So I will be adding clear mask. Essentially I'm going to fill this or flood it with clear mask so that we can somewhat reinforce the connector a little bit better, promoting its contact with the board. You want to be careful here. You don't want that stuff to go where you don't want it to go, because you might disable the locking mechanism for the latching mechanism. So you want to be careful not to put that stuff anywhere where it shouldn't. So we're gonna add a little bit, make sure that the latch is still working. There we go. So now I'm going to cure that, or at least try, and then we're gonna add some more until we're satisfied. Alright, the connector is done. Let's put the new battery in here and screw it on. Okay, now let's connect that connector onto the board. Where is it? Right there. So the latch is on. I think it looks fine. It latched right on, so I have no reason to believe that it doesn't work. One way to test would be to obviously put it together and power it on. So let's go ahead and do that real quick. Now let's click the power button and see what it does. And I'm guessing the battery is discharged, so we're not really seeing any activity whatsoever. So we're gonna have to charge the battery first. So let's go ahead and do that. Right, so it does work. The battery indicator is all the way at the bottom there. I don't know if you can see it. Right there, so it's like a 10%. So we're gonna wait and see if that's going to charge. Right now the AC adapter is only pulling 0.3 of an amp. I don't know how normal that is, but we're gonna wait and see if that battery actually works, because if it doesn't work, then we're gonna have to put the original back on. I don't think it's charging right now. The once I power the unit off, the AC adapter is not pulling any more than 0.03 of an amp. So we clearly have a problem either with the battery or with something else. So let's go ahead and ditch that battery, which isn't made to be done easily, and we're going to put in the original battery. Hopefully we can kind of squeeze that in without the need of disconnecting the screen, and see if the problem is either with the battery or with the connector. Or maybe it already has and I just can't see it. Yeah, it probably already has. Okay, so let's bring in the power, plug that in, and I am looking at the... Yep, it's pulling 1 amp. So the battery was bad. And if we were to power the board, let's see what it's gonna show us in terms of the battery. Because right, see, the good battery is the old battery is 55%. And if we were to unplug, it still runs. Whereas with the new battery, it wasn't even running. So at which point, I'm not exactly sure which battery is new, which battery is old. So I'm just gonna have to assume that the battery that was already installed was actually new. So I'm gonna have to replace that battery back again and try again. Alright, so let's ditch this battery here and put in what was already in here when we got the laptop. Out with the old, in with the new. It would be wise to connect the battery last. Otherwise, you have to be super careful with the ribbon cables. So anyway, the thing is working, and I'm guessing it's got Windows 11 on there because I'm stuck and I'm unable to continue. My guess it was a reset, and it's not allowing me to continue without connecting to a wireless network, which I don't want to. So I know there's a way to work around this, but I'm not gonna take my time to go and find it because I'm not interested. As far as the repair goes, we're done. Power off. This thing is pulling about 1 amp on the power supply, and most likely more than that coming out of here. So that will be it for this repair. Let me guys know what you think about this simple fix. Whether it was simple or complicated, let me know what you think about it in the comment section below. Hit the like button, subscribe for more repairs like this, and maybe we'll get more stuff, more interesting stuff coming in as we go, as we grow together. And thank you for watching. Have a blessed day, and goodbye.